All right, our last topic for today is to find the derivative of e to the x. And the way we're going to do that is we're going to start out by graphing the derivative of e to the x. So remember, derivative is the slope of the tangent line. And so what we would do is look at the slope of the tangent line here and follow it along, okay? I have a little picture that should help us see this. Here it is. All right, so we have e to the x right here. It's this black curve. And then this is my tangent line in red. And as you look at it, the slope continues to go from a very small positive number, and then it continues to get to a bigger positive number. And it continues to go up and up and up, okay? So down below here, we're gonna graph the derivative of e to the x, okay? So here it is gonna start out. Sorry, it's kind of already starting. We got our small positive numbers, and my slope continues to get bigger and bigger as it goes along. And you should start to see that the derivative of e to the x actually looks like our original function, e to the x. And that is true. That is the case. The derivative of e to the x is actually e to the x. Okay? So let's go ahead and go back to our notes here and graph that. Okay? So derivative of e to the x, we're going to graph it, will look like, this is not a very good graph because it shouldn't touch the x-axis. It'll get really close. Okay, my graphing is not very good today. Okay, gets really close but never touches, but they should be the same. Okay, because the derivative of e to the x is e to the x. So the derivative of our natural exponential function, e to the x, the derivative of it is e to the x. So it's like your favorite derivative. So let's go ahead and look at this. Example 6 says find d dx. Okay, you guys, this notation is just saying find f prime of x. Okay, so it's saying take the derivative with respect to x. So if I look at a, it's f of x equals 5 e to the x plus the square root of e. So I go to my x for the first one, which is e to the x. That 5 is a constant, so I know using my constant rule that 5 is sticking around, so this is f prime. So it's 5 times, then I take the derivative of e to the x. It's your favorite, it is e to the x. Plus, now if I look at this next part, there is no x, and if there's no variable associated to it, then that is a constant. And you can type it in on your calculator. You can type in the square root of e, and it will give you out a number. Okay, so you have to remember e and pi are not variables, they are numbers. Okay, and so the derivative of that is 0. So then I would just go ahead and write f prime of x equals 5e to the x. So there's my answer for example 6a. Now 6b is not as straightforward. It's not just an e to the x. It's an e to the x plus 2. So what I need to do is use a little bit of my rules of exponents to rewrite this one. We don't know yet until section 3.4 how to take the derivative of e to the x plus anything else. Okay. So what we would do is I would just remember we have x squared times x to the 7th. Okay. You guys typically go ahead and you're like, okay, I can put these together with addition. You forget though that you can actually go backwards. Okay. So if I have two things being added, I can actually rewrite it as x squared times x to the 7th. So let's do that here. So I'm rewriting, I'm not taking my derivative yet. I would have e to the x times e to the 2nd plus 3. Now I'm going to take the derivative of this first part. So I'm going to say g prime. And I'm going to take the derivative of e to the x. Now e to the 2nd, there's no x associated with it, so it's a constant. It's just like the number 5, so it sticks around. So I still have e to the 2nd times, now my derivative of e to the x is e to the x, plus the derivative of 3. 3 is a constant, so that would be 0. So I'm just going to go ahead and rewrite this. I would have e to the 2nd times e to the x. I'm going to put those back together, so it'd be e to the 2 plus x, or I like to write x plus 2. So that is my derivative for example B. Okay. And that is it for section 3.1.